Welcome to Tech and Test, where we unravel the intricacies of technology, delve into the world of software engineering, and challenge the boundaries of software testing. Your host, Peter Johnson, will help you navigate the digital landscape, exploring the latest in tech, sharing insights into software development, and talking to the people that drive our digital world. Now, let's dive into today's episode.
And welcome to another episode of Tech and Test with me, Peter. And in the studio here, I have James.
Hello.
Hi, James.
Hi.
Welcome to Tech and Test.
Thank you.
How would you describe yourself to the Tech and Test audience?
So I'm a mathematics and computer science student at Imperial College London. Basically, my whole world kind of revolves around tech. It's kind of everything I do. I also play a bit of basketball, badminton in my spare time. But yeah, I'd say that's probably my best description. There's not much else to say about my life as a whole.
Awesome. So you're studying maths and computer science.
Yeah. So it's a joint honours.
So which one of those do you think you're more interested in?
It's really hard to say. I mean, the reason I picked it is because I was so 50-50 in the first place.
Right.
I'd say I'm more of a computer science inclined person, but my passion's probably more towards mathematics, as reflected by my grades. So my grades for computer science are way higher than my grades for maths. But I'd say maths is definitely something that I've had it for longer. I've been doing it my whole life. Actually, when I was in year 12, the big decision I had to make on which course to do was so I did maths, physics, and computer science,
right?
As is done by most people that go to Imperial to study computer science. And I was debating between maths and physics and maths and computer science because I knew I wanted to do maths.
Right.
That was like a absolute for me. And then it was a question of which one do I want to do alongside it. And in the end, I decided on computer science.
I see. That's really interesting because you haven't quite yet made a decision on where this is going to go.
No, yeah.
But I feel like there's a bit of maths that comes into computer science anyway.
Yeah. So, going into university, I didn't realize how much computer science I always thought was like programming,
sure,
data structures, algorithms, that sort of stuff. But the actual field of computer science is actually a branch of maths. The whole thing is just maths. Things like formal proof, logic systems, all of that stuff is derived from mathematics concepts. So at least at university, the overlap is very, very large, which is why the course exists at Imperial, because they saw the sort of similarities between the two.
Yeah, that's really cool. I know there's some computer science degrees that define computer science in more business or applications, right? Yeah. Then you get a question, are they actually computer science degrees? Or are they software engineering or computing business systems? Or I don't know.
Yeah. Imperial's definitely more business inclined than say Oxbridge. So we do a lot of group projects, a lot of practical stuff, but we leave the option of research open. So if you want to do research in computer science, it's still very much an option for you to do. Yeah.
Awesome. And let's say we go 5 years into the future.
Yeah.
What do you think that's going to look like in terms of you in your career, or maybe in technology in itself? What do you think are going to be some big themes that are going to come up in tech, right? Based on maybe your experience or what you're studying or what are you hearing about? And also where do you think you're going to fit into this?
Okay. I think predicting where the tech industry is going to go has been historically a very difficult question to answer.
Yeah,
not many people do get it right. Obviously, right now the big thing is AI. Everyone's talking about it. Particularly in my course, which is mathematics and computer science, AI is almost the backbone of what we're trying to do right now. So I think I can't see AI slowing down anytime too soon. ChatGPT just released a new model. I don't know whether you've seen it, O1. There's a lot of stuff being done, a lot of research. Other than that, it's really, really hard to say. I mean, if you asked me 5 years ago whether AI would be at the level it is now, I would have told you were crazy. So I guess I try not to think too much about what it's going to be like in 5 years in the future. Because in the tech industry, everything can change so drastically. I think it's, for me personally, I try to focus on sort of the tools that are being used right now, being developed right now. As for my career, it's hard to say. So I've just done a software engineering internship. It's my first proper one. So I did a short sort of placement at a local company last year when I finished my A-levels. And I learned a lot more here. But all of my industry experiences have been very much computer science related so far. So I do want to try and explore sort of the maths field in industries, the kind of jobs you can do in maths. So you have quant, investment banking, a lot of finance stuff. And then also the other thing I'm considering is sort of research. So my whole life, I thought research was like a university thing. So you did research and you did teaching. Right. I really didn't want to teach. That was definitely something I wanted to avoid. But now research is done by like loads of companies, right? So you can apply for like roles as research scientist or stuff like that. So it's very much like a university kind of environment, but you don't have to do any of the teaching. So it's quite a cool job idea for me. And the other thing with maths is that is for the kind of jobs that use maths. There's always going to be jobs that use maths to a certain extent because maths is so like abundant in science. But the kind of jobs that use it sort of change quite a lot. And so having a good foundation in that sort of aspect is something that I want to try and make sure is good before I try and explore all of these careers.
Yeah, I love how you're keeping loads of options open. I think that's awesome because I think sometimes I'm quite skeptical about, this is my personal opinion, about educational systems that they tend to get you working a job really quickly. So you start paying tax.
Yeah, yeah, of course.
But I kind of think it's good to kind of consider all options and not like leave anything on the table, which I think is pretty cool. Like, you know, setting up a business and really getting experience in. And I think maths is really interesting. I have a few friends who work in like the quant space, but you know, I think that you've got to enjoy the maths, right? There's one thing of like doing maths, and there's one thing like I actually enjoy maths, and I'm actually enjoying to be. And I think they've struggled because they've not enjoyed the maths, right? But it sounds like you actually enjoy the math.
I do. So quant is notorious for being one of the most competitive and fast-paced and brutal industries to work in. It's famous for it.
Yeah.
A lot of people like it because it's high salary. So they get it's very appealing, especially to a university student. But it also comes with a caveat. You're working 12, 13 hours a day.
Yes, very true.
It's very hard to take leave. You have to really enjoy what it is you're doing. For me, it's something that I definitely want to try. I don't know. I believe, my personal belief is that right now I do really like maths, and it is something that I could do. Especially Imperial, they work you to the bone anyway. You're doing around 12 hours anyway.
Right.
But I guess I won't know until I try it. So maybe that's something I'd like to try next year and get a feel for it.
Awesome. Yeah. I always have the attitude of like, just try something first, because you never know. You can always hear people's stories and go, oh, I worked here, or I did this, or I tried a startup and it didn't work. I think you never know until you've tried yourself, because it's almost like you've got every human wants to have their own empirical evidence of like, did it work for me? Because I think comparing other people's stories is always a bit difficult because there's different backgrounds, maybe different motivations and interests and different scenarios, right? So I think it's cool to keep options open. And I really like how you're super interested in maths. And for me, I'm into astronomy actually. And one of the barriers I have getting into astronomy is I don't really study maths a lot. And astronomy is a whole bunch of maths.
Yeah.
So it's kind of interesting how I've kind of studied computer science to get away from maths a little bit. But actually, the more you want to study the universe and understand like the space and time that we live in, the more you do need those tools.
Yeah. So. I think maths is sort of very much the way like the universe speaks in a way. It seems to be the language that it speaks, because it's so intricate and it models everything so nicely. It's just, I think that's probably fundamentally the thing that attracted me to maths most was that kind of thing. Obviously physicists will do a lot more of that sort of stuff, whereas I sort of work in like a pure math sort of field where we just deal with groups, rings, all of that stuff that is sort of very detached from astronomy. But I did do astronomy at A-Level. So at A-Level, I did physics, and AQA, which is the board that did physics for my school, you have a extra module that you take, and it's up to the school. Well, it actually depends on the school you go to. So for our school, the school picks it for you. Some bigger schools, if they have more money, they can have enough teachers to sort of let the students pick their own module. But the school picked astrology.
Astrology.
Astrophysics, not astrology. Astrology is the
sure,
the less scientifically based one, right? So astrophysics, it covers all sorts of stuff like life cycle of stars, how to use telescopes, like sort of lenses.
Oh, really cool. Yeah.
All the maths involved. So yeah, that was also really fun.
Awesome. And can I ask you a question? So do you believe there's extraterrestrial life?
I'm going to say I'm inclined to say no right now. I don't even really know the reason. It's kind of just something that
Your gut feel.
Yeah. I feel like if there were, we would have some kind of indication, right? It was like, if you base it off statistics, someone says like, it's very likely that there is life, right? But we haven't seen any indication of it. We've looked for as long as we've lived, but it's almost sort of fitting that we're the only ones, you know? Almost. It's like, it's so against what stat says that it seems to sort of be the right thing. There's actually there's a maths problem. It's called the Riemann hypothesis. If any mathematicians listening to this will know what the Riemann hypothesis is, and I won't go into the details, but basically the hypothesis says that all the answers to this problem lie on the number one, and we found trillions and trillions of answers on this number line, and all of them match the descriptions, but we've never been able to prove that it's true for everything. And I think there are certain mathematicians that sort of want it to be false,
right?
Because it's sort of like, it looks perfect, but we haven't been able to prove it, so maybe it's wrong. Maybe there's one thing that isn't on it. And I think it's sort of a similar kind of logic. Is like, there's a part of me that sort of hopes that the stats is wrong almost. Like, it would be a cool fact to know. But I don't know. It's not something I try to think too much about.
Yeah. I think you're right. I think there's a lot of other problems we can focus on.
Oh yeah, there's also that argument. It's like, is it a waste of time or something? Which I don't think it is, personally. Like, if that's something you're really interested in, then you should definitely go check it out. It's just, I'm not really in that field, so I wouldn't like spend too much time thinking about it. It depends on the person, though.
Awesome. So James, I'm just changing tact a little bit here. So let's imagine I've created a new startup, and it's going to be, I don't know, I'm going to create an app, or I'm going to create a web app, or I'm not sure what kind of app yet. Someone tells me that you're really into like languages and like programming languages, and
yeah,
you may even say it's a hobby, right?
Yeah.
What sort of languages do you think are sort of trending at the moment?
Trending. If it's trending, then I think the first one that comes to mind is definitely Rust.
Right.
Rust is it's been trending for a while now. I don't know whether you've seen the Stack Overflow. They do that survey every single year. Rust is always most loved. It's definitely my most loved language, that's for sure. But there's a bunch of new languages coming out. So there's one called Zig. Zig is a systems programming language. It's designed to replace C. Well, not replace, like sort of help with C. And then there's one called Carbon. I believe that's being made by Google. That's for a C++ replacement. One of the most sort of complete new languages is Kotlin. That came out about quite a while ago now, like 8 years or something. That's the Java, more modern Java. Go as well. There's a bunch of new languages that are becoming more and more popular. For your startup, I guess it really depends on the use case, right? There's always the question of, should you use one of these new languages for your startup, right? Because it's risky because all of these other languages, they might have their flaws, but people have been using it for decades now without any problems. Like C's 40 years old now. It's still the easily the most used language in all systems programming. Java's been around forever and it's still going strong. I would say if you're making an app, for example, then Kotlin is definitely the way to go for me over Java. Reason being is it's maintained by like a good team. It's backed by JetBrains, which is the creators of all the Java IDEs and all that stuff. And so it's got a solid future and a solid foundation. The same can be said for Rust in a way. So Rust is open source. So it's maintained by the Rust Foundation and then a community of developers. And it's also, I feel like it's gotten to the point where this is like Rust it's an official language. People can use it for things that they want to use it for. I would still be very cautious with using Rust. Because although we have seen it used in many projects, very few have reached the scale of like Amazon, Google. They usually use it for sort of like a tool, either internally or like it's never going to be a very large tool that's built purely in Rust. At least not at the moment. We haven't seen it yet.
Because I know in the Python space, like Pylint used to take ages on like really big projects.
Yes.
And recently we've been seeing like an influx of like tools written for Python now written in Rust, but for the Python ecosystem. Yeah. And like Rough was a good example of that, right? Where, you know, the linting actually took a few seconds out, where before maybe with Pylint it would take, I don't know, minutes to lint. So I think like you're right. We've seen like examples, case studies of like isolated tools, but we haven't seen like projects at scale, which is a good point.
So Rust is risky for a startup, I'd say. But if you're trying to make like an application either for yourself or maybe just as an open source project, then I'd say Rust is a really good choice. And Rough is a really good example of that. Rough is incredible. It saved me so much time. I don't understand how they made it that much faster than Pylint, but that is one of the... And the other thing is, if you want to contribute to these new open source projects, then learning these languages is also pretty useful, I'd say. It's also a good way to learn them. Like if you're used to contributing to open source and you want to learn a new language, then contributing to like Rough would help you a lot with learning Rust as a programming language.
So what's your philosophy then on... you know, there are some software engineers who kind of specialize in languages. They become really idiomatic in learning the language, knowing like maybe how the language is implemented. You know, like for example, C Python, knowing all the details of how C Python works under the hood. What do you think your feeling is on how many languages do you think someone can be really proficient and idiomatic at? So, you know, I think we can all pick up a language and maybe learn the syntax and like build something quite simple. Yeah. But do you think you can be like really an expert in like 5 languages and know them really well and be idiomatic at them?
It's interesting. So I don't know whether people can relate to me on this or not, but I forget how to program in certain languages very quickly. Like if I don't do it for a month, I can't even remember how to do a for loop in certain languages. But I can pick them up relatively quickly once I've learned them the first time. And I think a lot of people agree is that once you've learned one programming language properly, picking up the rest of them is like, oh, this is all really the same thing. Like there's a few like differences here and there, but it's all just syntax at the end of the day. As for being a proper expert, so I would deem like an expert at a language to understand, first of all, like the internals, how it handles memory, things like concurrency, you have to understand really well. Then also the semantics of the language. There's a whole module, multiple modules actually at my university and other universities. It's programming language design. There's a lot of mathematics that goes into designing a programming language. It's not just something that like you can just write and make it well, like work well. So to be an expert in to be that level of an expert in any language, you have to know these design principles. So I think that locks off, I think, about 80% of people at being a proper expert at a language. Because there's a lot of mathematics involved. Not everyone wants to go into that sort of depth. Then once you have learnt those, from what I can tell from like my supervisors at university, a lot of languages follow similar sort of design principles. So object-oriented programming languages like Java will be similar to things like C#. The difficulty comes when you look at languages that serve a unique purpose. So, for example, Rust is a good example of a language that is designed to be very different from all of the other ones. If you want to be an expert at Rust and be an expert at like Java, I think that is very difficult. And if you can manage to do that, it's very impressive. I myself, I can't see myself becoming that level, like that good at more than one of those languages. It's not really something I plan on doing either.
Yeah, I think being an expert in a language takes a lot of time. So I totally agree with that. Just changing topic a little bit, James. So now you've just finished 1 year at university, right? Pretty much. So you're entering your second year?
Oh yeah, we're into the second year.
What advice would you give, I guess you've learned quite a bit already, and what advice would you give to yourself maybe 5 years ago or a few years ago do you think would have been valuable?
Okay. I'm going to try and avoid saying advice that is like it's something that is in hindsight, so I'm not going to say like for like invest in Bitcoin or anything like that. I'll try and talk more about like life advice, because it'd be very easy for me to say like maybe there's a particular concept I struggle with right now,
sure,
and tell myself to learn that, but that's not realistic. Something that I think I'd like maybe sort of regret from 5 years ago. Let me think. That was around GCSE time. Yeah. So I think around GCSEs, you'll hear this from everyone, but GCSEs is like not as important as like A-levels, for example. But I spent a lot of time revising for GCSEs. Maybe potentially even more than A-level. And I put a particular focus on subjects that I struggled with. So like languages, so German, and then subjects that I wasn't that interested in, like business. I would tell myself to do what I enjoyed at that time, because it's very easy to get hung up on the numbers you get after you do your GCSEs.
Right.
But the truth is that honestly, after A-level, no one cares. Your teachers will tell you otherwise, but no one looks at your GCSE grades once you have your A-level grades, except for maybe unis. But other than that, it's not too important. It would have been a much better use of my time to really sort of focus on the subjects that I knew I wanted to do. So I knew I wanted to do maths, physics, computer science from like way back in potentially year 8 and 9. But I chose to sort of ignore that. Right. And focus on my other subjects just so I could get the like good looking grades. And the thing is, once you get those grades, everyone will congratulate you and stuff. But for me, I think I really should have spent that time focusing more on what I planned on doing rather than the numbers that I'd get from the result. That's one of the advice I would give myself. And I'd also say for A-level, I'd try and it sounds very like egotistic, but I think my A-levels went pretty well. Other than the fact I applied Oxford, but I didn't get in. I'd say again with A-level, try not to focus too much on the grade you'll get at the end, because it's not really important. This is your once you get to A-level, you've picked these subjects that you want to do. You really want to get as deep into them as possible, not just the stuff they teach you at school. There's all of these subjects, and I can say this for every subject, even though I've only done 3, is that there's so much more to them than what you learn at A-level. A-level is very important, but that's not it. Like, especially say maths, uni maths is so different from A-level maths, because there's just, you don't realize how much stuff really goes into the stuff you learn at A-level. It's hard for me to put into words, but I would really try and look further than what you're learning right now and really understand what it is, this subject that you like so much. What is it? what is it made of, and what do people in the past like have to do to get your subject to this level. And I'd also say that really helps with applications. So any interview process, they test your technical skill, but a big percentage of it is they're looking for your passion, and you can't fake it really. They can tell when you really like a subject and when you sort of in between the subject. Because I remember when I did my Oxford interview, I did the computer science one, and I was really into computer science. I'd done a lot of programming. I'd done a lot of like algorithms and stuff like that. And they could see when we were talking, it felt more like a natural conversation rather than an interview.
Right.
And when I did the maths one, maths for me was like, I'd sort of neglected maths for a long time. So GCSEs, I basically didn't revise it because I was really good at it. And I sort of just ignored it. And then at A-level, it was still okay. So I only revised a little bit. But they could see that in the interview. And it really felt like they were interviewing me rather than us just having a conversation.
I think it's really interesting what you've said there. And I think it's really good advice. Like, in general, right? Maybe not applying just to like GCSEs or A-levels. It's like really stick at something that you're passionate about. Because really, at the end of the day, you can do an academic course and you can, score well in the coursework and the exams. But really what's going to get anyone through, I think, is that passion to really continue doing it and to really like spending weekends and evenings doing what you love and enjoy rather than, okay, I'm studying this data structures and algorithms course because I have to.
Yeah. Yeah.
But actually, like, I'm curious about these algorithms. I really want to know how they work, who invented them, why have they been improved? Like quicksort, who invented quicksort? How was that implemented? Having that curiosity and that passion.
Yeah.
Versus just, okay, I need to memorize this, right? Which is the opposite of just, I want to do and study that course because I have to.
Yeah, yeah.
And I think it's an interesting piece of advice. And I think that's that's valid, I think, because you can't tell people to do something they don't really enjoy. Eventually, it's going to catch up with them.
Yeah, yeah, absolutely.
James, I want to thank you for coming on the podcast, for coming on Tech and Test. I just want to ask you if there's anything you want to sort of like leave out there to the Tech and Test audience, any sort of final messages?
I mean, it's all tech people, right? I think it's just that all of you lot work in a very exciting industry. It's definitely the forefront of everything the world is doing right now. So yeah, just give it your best and make sure you stay enjoying like what it is you do. And yeah.
Awesome. Thanks, James. And thanks for coming on Tech and Test. Really appreciate it. Hello, it's Peter. Thank you for listening to this episode of Tech and Test. I personally appreciate it, and I hope you got something out of it too. If you're interested in subscribing, please do, because then you don't miss any episode I've created. And you can also visit techandtest.co.uk, which has all the episodes I've created. And you can visit peterintest.com for my personal blog too. So I'll see you on the next episode.